buses and trucks. If you really bringing electric transport system for those vehicles, like, are you able to follow? So you would need a 4 charger. 1 car, 1 electric vehicle and 4 chargers. Typically is mandatory required for. If really want to make a car to be pleasant for the people who drive the electric car, I mean also. And they are ready to pay for it, no doubt. Well, to support this, 1975, this wireless charging, wireless power transfer of 30 kilowatt, 1.5 kilometer was tested here, okay, typically. But taking a next, in 2007, MIT researchers have tested wireless power transfer. Tesla last research in 1885 around was on wireless power transfer, and it was a Tesla tower in US, which I think they destroyed in last year or 2 years back only. He considered to be fail himself on wireless charging. Induction motor he developed, that's the reason induction motor Tesla invented and all that. But this technology he failed. You know why he failed? Because it was not the right time for launch of the technology. Technology was good. 2007 MIT, after 125 years of 1885, MIT repeated the experiment of Tesla, of wireless power transfer. And after 2011, Nissan, Renault brought the wireless chargers. Within 4 years, product was launched of wireless charger. And now we are saying after 14 years or 15 years, yes, whether we will lead wireless charging. However, lot of industry are manufacturing this wireless. So you will not find any vehicle maybe after 5 to 10 years that they will have a, and requirement I told you why. If you are paying good cost, you need the comfort and probably it becomes necessity tomorrow. The mobile is today necessity, not the, we do remember in your mobile phone in 2000, when it was introduced, 16 rupee per minute was the receiving call charges. A person who have a mobile, he keeps always in hand. You know why? To show, I am a dignified person of society, I have a mobile. Okay, kind of things. Okay. Yes, maybe 2011 Nissan bought, maybe it's looked like that technology, but think about, Tesla put this technology in 1885, nobody was user up to 2007, even for experiment repeated by MIT, and 4 years product launched, and today 25 industries manufacturing this product in the world, this wireless chargers, like, and lot of research. I mean, like, I have not put in my research because of vague, and at least my 4 colleagues in my department are doing research for wireless charging, and the student of those lab are crying because you don't have a component for facility for doing the really research on this wireless charging, because industry have to support the material and other things like. So what I mean, like, and how fast? 120 meter to 7 minutes. Probably 7 minutes also is not affordable, na? Petrol car, you can fill the petrol in 1 minute, na? So 7 minutes is also really taxing to the people. Why you have to wait for 7 minutes? Your car is still not suitable for the public. Your electric car is not still suitable for public, na? Because it's still taking, you brought from 120 minutes to 7 minutes, but 7 minutes is also too long for the people to make equivalent technology of electric, your normal petrol car. So you have to think something better than that. The challenges I am talking about, okay? Think about that. Okay. Well, this is the slide, of course I may repeat it. I found it quite interesting for what the topic probably wanted by the organizer, that we should have a renewable base charging scheme or charging station. Yes, it gives the answer which I saw probably around 8 years back, around 10 years back, and I put around 8 to 10 PhD students working on it. Well, it's a good slide. Okay. You know what we have? We can take power from the grid. Okay. We have a power from PV, we have a power from wind, we have a power from fuel cell, and as well as we have a battery for power leveling. And then only you can put the fast charger as well as regular chargers. I mean, even because if you say fast charger, and in the previous slide we say 1 minute 350 kilowatt, if you want to have a 3 kilowatt, 4 fast charger of 350 kilowatt, think about this, how much it is, megawatt. Are you able to follow? Like, Government of India at the moment, they are not allowing this more than 250 kilowatt. We expect they will allow this more than 250 kilowatt to be one charging station. Otherwise, you are expecting 350 kilowatt for one fast charger, then how will meet this probably typically or 350 kilowatt for one charger. So, you need certainly more than 350 kilowatt for several one and regular also. So, you have to take power from here, you have to take from PV, solar, as well, wind and solar and fuel cell as well as from the battery. And when you have no charging is there, you charge the battery here, you put to the grid also. Of course, you can do the power leveling, give the fixed power to the grid, okay. Don't allow the power to change to the grid because you have already the battery which can take this intermittent nature of the power flow, typically like So, do you consider that it has three kind of renewable, wind, solar as well as the fuel cell. So, I asked my student to start with one source, then two source, then three source, then four source. Which is the fourth source? We consider the hydro. Your canal side, you might have a canal side, zero head power like. Many industry really remarkable load, okay, you can very good configuration. So, not necessary PV and wind, might have a small hydro as well as fuel cell and battery along. Battery is for power leveling, where you have intermittent power here, intermittent power here. So, certainly you need the battery too. And this is also intermittent charging. Sometimes vehicle is coming, sometimes vehicle is not coming. Are able to follow. So, to meet this requirement for power leveling, you should not take suddenly a large amount change of power. You can take fixed amount of power here, and if you are not able to use, of course, you can charge, otherwise you can reduce the power taken from the grid. So, grid should not feel there is some exertion. You can take power from the grid, you can feed the power to the grid, but feed the constant power or take the constant power. So, that grid does not really experience any variation, for which you are authorized to draw power from the grid like ours. So, of course, the student got a good recognition. I think majority of them are serving in a reasonable good industry and getting good salary, varying from 20 lakh to 40 lakhs in India. Of course, in different city. I don't tell to them, otherwise which city I go, probably 5 to 10 students are working in industry like. And many industry are really very interesting product like which we did 15-20 years back. They are in multinational are now doing research in India for practical applied research like also. Well, interesting, I found probably, I think my student found something from this side. You know what? You have a solar and you have wind. And you know what is the capacity they expect? That this can generate it 2 lakhs 34,154 units per year, which provides 8 lakh 10,000 miles of emission free driving in a year. When you have a requirement, there is a innovation in the life. And this wind turbine can run in many such low speed, you can have even daily top building also along with the solar, okay, typically. Or in Gujarat, if you go to Dandi March, I have seen the what called solar tree. So, you can have such kind of turbine as well as solar on the top of it like also. Well, this your charging technology. With the smart grid, we say V2 grid, vehicle to grid, which I already talk about, okay, why need the bidirectional charger, I mentioned it. Then vehicle to load, I also mentioned domestic inverter concept. I hope you understand, like a proper rating. Then your vehicle to home, you can charge your vehicle, okay, or vehicle to vehicle. Sometimes it's stuck in the way, you have to take there also. So, this we call it like a V2X technology and related to vehicle charging. So, this technology, if we talk about vehicle home, why you might have a solar panel on the roof? I don't know whether you heard about the industry called Enphase. They interacted me during COVID period. A startup started in 2006 in California, and their stock up to 2019, 2006 to 2019, their stock was $6. Their share was only $6. Okay, but 2019 to 2021, their stock gone to $176. And they don't put their product on the website. They showed me the complete online what product they are. You know, they were making a kind of in the solar roof, a battery energy storage in home as well as small DG set, smoke light for a home and mainly for electric vehicle charging. 3 kilowatt and 10 kilowatt. And they have a 2 more product like your big ambulance, 10 kilowatt panel, a battery energy storage and a small DG set with the CNG kind of arrangement, not petrol, diesel. and like a portable charger, portable fast charger, which is required for such application. Are you able to follow for such application? So these were the only two products, 3 kilowatt and 10 kilowatt. And you can understand, and they came to Bangalore also, they started, and they started spoiling our students. They say, we would like to take MSc student, but will offer 25 lakh salary. So my faculty colleague also really burned their hand. Whether they do something in project and sir, we got the job, we want to go it, okay. You give the lower grade, does not matter for us. Like, so they started, but of course they say the guys should have it throughout first class or some 75% above. Other criteria they put it. But I don't know, they inducted for solar pumping with me, can we go to in solar water pumping? That another application, like, so they, I mean, gone from somewhere that, okay, we are working in that area, typically that. So I hope you got some idea. The charger have a strength related to vehicle. Vehicle is interacting through charger only for all these technology, like, I mean, also. And coming to a little bit now back to electric vehicle. Can you think about this electric vehicle, what miracle, 215 watt, two-wheeler? And what is the battery rating? 4820 ampere hour, 0.96 kilowatt hour, so less than 1 unit. It drive around 65 kilometers. And the hawkers have a similar vehicle, na? Your Swiggy hawkers, your Zomato hawkers, they drive with this kind of vehicle. Of course, that vehicle is very raw, costing around 20,000, 25,000, like. But this vehicle is, you know, little bit better, safe. You know who drive? Who like this drive vehicle? Girls and ladies. And because of Indian culture, na? Neither their dupatta should fly, neither their sari should fly. So speed limit is 25 km per hour by government. Okay. But how much energy efficient? 0.96 kilowatt hour, 65 kilometers. In 5 rupee, you know, 5 rupee, you can go to multi-story in your lift, charge in home and come back. Okay. And drive so cheap. 5 rupees, 65, 10 paisa per kilometer. Are you able to follow? Even a cycle may take more. I mean, if you really look into, and that's the technology too much for its last mile connectivity, 5 km, 10 km, if you are really going to your office, considered to be so small rating, like a 250 watt motor only. Can you think about a two-wheeler with 82 km, 82 kilowatt motor at 5000 RPM? Who drive it? The guy is smiling, yes, he drive it. You know why? Maybe on the back a girl is sitting and he want to make this as an aeroplane. The boy, if he is driving, if girls is on the back, he want to make this aeroplane and it can become only aeroplane with the 82 kilowatt motor, not less than that. Okay, that's the reason industry introduced this. Okay, 82 kilowatt. This is also two-wheeler. Yes, it's a practical, you can see. That is more than double the car. Of course, I might have a slide, unfortunately it's not there in another presentation. The car itself have a how much? 18 kilowatt. Many cars in India manufacture 18 kilowatt motors. I don't know, and this is 82 kilowatt. Why? Because the teenager don't want to drive the car, he want to drive this. Because girl will not agree to sit in the car, no? She will be happy to sit in that. Okay. They want to drive it, okay, that way. I have another presentation, not with so much photograph, with this kind of, okay, or so. 3 kilowatt hours, lithium ion battery, like, maybe, no, not 300, maybe like a 240 volt order of that, like, it depends, like this much, I mean, 14 kilowatt hours into it, like, also. But torque, big torque, 190 Newton meter, like, just to tell you. So these are anyhow little bit application oriented, one two-wheeler and another two-wheeler. In electric vehicle, see the diversity of your electric vehicle, okay, only of two-wheelers, like, and typically coming to your commercial vehicle for India is your three-wheeler, like school children, I mean, like 1 kilowatt motor. This also run around 80 kilometer, like typically. And another kind of two-wheelers Then four-wheelers. Of course, I mean, this is typically how much? Of course, the Tesla car, all-wheel drive, of course. So this is give an example, so much luxurious car is using only 18 unit of electricity for 100 kilometers. So 18 units means 90 rupee electricity, 90 rupee you are able to drive 100 kilometers. So it's less than 1 rupee. I mean, like Tesla car which have air conditioning and everything. Very luxurious cars takes around, let's say, between 80 rupee, 100 kilometers. So 80 paisa per kilometer, approximately, like also, including all the features into it. But you may see from where other electricity is coming, energy coming from regeneration, part of it. Otherwise, you cannot meet with the 100 units entire your typically air conditioning, other features also like. So I hope you have some idea of an electric vehicle, why it is needed to. Well, why for mission is required in India? We have a couple of missions. 250 crore mission from NRF. Prime Minister Office monitoring 250 crore mission. And 175 crore by other ministry like MNRE, this especially MIT and Power Ministry. So Government of India has put already for research around 400, only for EV directly, 400 crore for you people, for your research. How much you can loot, that is on you. Okay. I have been put a committee to check that it is not a loot, it produces something. I told, if you want to loot it, we cannot really control it, okay? We can think about something comes out of this, like also. So anyhow, what is required, people expect the development of novel and new solutions and development of new and efficient electric motors for EV. That's the reason even recently another mission put rare earth material mission. I think the Government of India is committed to have a plant for rare earth material. Rare earth material, you understand, permanent kind of a high quality permanganate, okay, neodymium iron boron, that plant they are going to put. Of course, we also have a third in the country. I was looking even yesterday newspaper, we are third in the rare earth material in the world, but that's not efficient according to the population. I mean, we have a probably, I think they were giving some, I think 800 tons or 8,000 tons or something. China have 48 tons, so 6 times the rare earth material. But the requirement, of course, our requirement may be more than China. So the plant is supposed to be there, like also. So then novel, then your charger, on-board, off-board and wireless charger. I hope it is up to 430, it's okay? 430? No, it was given time 2:30 to 4:30, bhai. It was written in email, I am just going to, somebody bell it, na? So I think alarm is 4 o'clock, but I was giving 4:30. Okay, no. No, if you are getting bored, I think I am not finding anybody sleeping here. Okay, after good lunch, people are probably enjoying it, stand up. I'm like, so then new on-board charger, wireless charger and multifunctional charger, and of course capital reduction on EV and operational research cost and employment generation. So I asked the mission being associated with that, every researcher have to go to industry and some time for implementation of exposure. Involved industry person have to go to academic institute for research component and enhancing qualification. And outcome of these mission are expected to technical manpower development at BTech, MTech, master and PhD level, and of course publication, patent, product, and of course startup and jobs. So that is I asked them to have, if they are asking my involvement in both the mission, about 250 crore worth, I told I cannot do too much justice, okay. I have to have my own bread and butter, okay. That does not give any bread and butter, it's only, I can do something for country, but don't put too much load. We can only give initiation, let the other people policy and other people should execute it also. But we expect it has a very big opportunity for the employment also and for you people also for, in the area it's so fertile that you have a research, next day you get the job with no problem. Like. Now let's come to my lecture a little bit. I have not started my lecture. Warm, I thought I should warm up na, with some stories, okay? Okay. Of course, common sense. Electrical engineers should have a better common sense than the general person. Na? So that's I thought it, and I can tell you, you get good, you can get a job if you are able to tell, okay, I know little better than what you people are as expert who is interviewing you. Okay, I thought this looks to be much better for you. May enjoy it, and I hope you enjoyed the talk so far. Okay.
ईवी के इंटरव्यू में तो यही सब पूछा जाता है कि स्कूटी का मोटर का वाटेज कितना है.
I don't know, maybe. So, what is the Beckler requirement is the constant torque, constant power application. Constant torque initially to start with constant power, this kind of characteristic, and torque is speed characteristic of this nature. And what your engine give, this is the torque and this is the power, which does not match this requirement. Okay, so what it is done? They put mechanical engineer put the gears, and you know that is the way you learn in life to live. Okay, that was the only way. If you don't have any other way, this is the way that you have to move the gear like this. Are able to follow? Like, if you don't have any other alternate, but we have alternate. Yes, you don't have to touch at all the gear. We have a technology now with the electric vehicle. You don't have to touch anything. Of course, mechanical people also brought the automatic. Okay, you might have heard you don't have to change the gear, but still, I mean, there you have to think about back and I think reverse gear you have to put it. Here we don't have to worry about the reverse and all that. So electric motor can do that, like. But in electric motor you can think about the wheel runs at very low speed. No? Wheel runs around 300 RPM maximum, no? Like 300, 400 or 500, not more than 600 RPM your wheel no? Move on the road, 600 RPM. Yes, we can make the motor at 600 RPM. We make the motor like a ceiling fan typically on how much speed? Around 300 RPM, 265 RPM. That is the typical speed. We have a motor of this. But the reason being that's a small reading and efficiency is very low. So we have to, if we make a motor in high speed, are able to follow. The benefit of the motor is suits to the vehicle propulsion. If we design the motor on high speed, what will the benefit? High speed means you have to use the gear, but you may use the single stage gear. But what is the other benefit? Benefit is your motor size is reduced. Your output power, output equation d square Ln. N you increase in the any electric motors, then d square L will reduce. D and L are the diameter at the air gap, and L is the stack length of the motor of radial field. Like, okay. So your d square L, so if you NS, if you increase from 300 to 3000, your d square L will reduce to 1/10. And that's exactly in e-rickshaw motor is there. E-rickshaw motor itself is 3300 RPM and then gear of 1 to 10. Because the motor size will reduce. The motor size reduces to 1/10. Cost also reduces drastically. Size also reduces drastically. Weightage also reduces drastically. So tendency is now, you might have seen the motorcycle, motor was at 5000 RPM. Are you able to follow? Motorcycle never run more than 300 RPM the wheel. Are you able to follow? But we are putting motor of 5000 RPM because the weight will reduce of the motor. I mean, size, weight, volume will reduce like, I mean. So we have to design the motor, and you will not believe, now the motor is coming even as high as 30,000 RPM. The research, when there is a demand, there is a research like. People initially go on 5,000, 6,000 RPM, then 10,000 RPM. I mean, my student in working in an Australia-based company, you know, they are developing a motor 30,000 RPM for Chinese company in Australia, a classified item. I mean, like, so the very purpose of reducing, I mean, increasing the speed, your size of the motor goes quite small. So all the motors which you develop, it even you might have seen the hub motor. Hub motor also have a gear. Motor might be running 3000 RPM, but your wheel runs hardly 300 or 200 RPM. So gear is in most of the electric vehicle motors, there is a gear now. But that is a fixed ratio gear, maybe 1/10, 120, 1/5 or whatever. It depends on what the speed of the motor is maximum like. So that reduces the size of the motor, cost of the motor, weight of the motor. And if losses reduce, efficiency increases. So your challenge for cooling also really get improved like. That is just to give idea that, okay, in city driving, it have a 100% gain means you have a reasonable regeneration in hybrid even. Are you able to follow? And highway it is 34%. The gain is corresponding to just to explain about the regeneration, okay. I mean, like, even in metro, you know, this fourth phase of metro, we were in audit team of first phase and fourth phase. We travel on Shahin Bagh to IIT, it was 43% regeneration. The company won the case from Supreme Court only on the basis that we provide in metro 40% regeneration. If metro have a 40% regeneration, think about, car might be stopping many times, not on traffic light, But when there is a heavy vehicle in city, you have to slow down. And you recover the energy through regeneration. So in city driving, certainly you have a more gain as far as regeneration is concerned. So of course, the reasonable depending upon many, company even in hybrid also mention about this regeneration, because they have to show how you are going to increase the range or something like that. Then of course you are aware that okay, I can probably skip the slide. So motor technology I have already talked about. I need not to talk about too much about. So initially Riva used the DC motor, but nobody is using DC motor. We have a very bad experience with the DC motor. I think I do remember in 90, BHL developed the four-wheelers with DC motor. And within 1 year, all the four-wheelers that called Tum, I don't know what is the name typically, that was replaced Ikka Tanga to go to around Lal Killa and the old Delhi railway station. But all were parked after 1 year near Lal Killa because they were using the 4-quadrant chopper with the DC motor. And the DC motor have a bouncing on the brush and commutator. And once bouncing means circuit get open. So this give you, and your armature have a very large inductance. So large LDI battery, all the devices fail of 4-quadrant chopper. So it couldn't work too much. And after that, of course, Tesla introduced the induction machine. You know about the Tesla story. Why he introduced? Because Tesla invented the induction motor, so he wanted the same name. Fortunately, in 2006, Tesla name is also not considered to be patented. You know, this big industry have a concept even patenting the name also. So after 125-year patent right gone, so you can use the Tesla name, okay, something. So they use. So they use initially induction motor with copper die cast, and they have a good, only 3% full load slip and have a good efficiency. And still I am convinced, working in around, let's say 40 years in induction machine, I consider induction machine still better than, for energy efficiency it may be better than permanent machine also. So induction machine, many industry have used it. These are some of the example, okay, which induction machine use it, okay. Then permanent machine, of course, every manufacturer is using permanent machine now. So need not to worry about so many manufacturers are using permanent machine. This is considered, even this also, your earlier slide which I have shown, this we are looking, that's also used interior permanent synchronous machine. You know, this is the invention of last, you can call it about 15 to 16 years, that the permanent machine, interior permanent machine is completely different than what it has been earlier. You are using a saliency of 8 to 10. It's an inverted synchronous machine. There is a flux barrier in which you put the magnet. The D axis become Q axis and Q axis become D axis. Completely inverted synchronous machine also. I think you can think about like a kind of vehicle. Yeah, I hope you see that why 52 kilowatt motor is there in this motorcycle, okay, also. And probably this might have many four-wheeler have a less capacity of the motors, okay, these are, I think I already talked about, so I can skip it. This also, I think, for three-wheeler. People are crazy to put your solar on the vehicle. And they claim around increase of your 40 to 50% range, that energy coming up, and or you can reduce the battery capacity They put the solar on the not only top, on all sides. Indians are crazy, no? So all people will see, no, when this e-rickshaw will move. And day by day panel is, also Nescafe soap. Your e-rickshaw have every commercial activity. The guy take to Lal Killa with the ice cream, this India Gate to ice cream vendor in the evening, and he brings in with no problem So different activities, children, then ice cream soap, okay, and then your garbage, and then your vegetable soap. You name the activity, it is all there in your three-wheelers. So you can see maybe 5 crore e-rickshaw is already in India. Every 50 lakhs is every year added. You make a small part of it, improve it. You will be selling quite large in number. Probably my couple of startups have done something, and they have a good requirement coming up, just to replace Chinese motor Then switch reluctance motor, that's even manufactured in India as well as UK and many part of the world. So Indian company is manufacturing in 1971, that company was there, and they are developing switch reluctance motor even for a four-wheeler also. So anyhow, that's, and e-rickshaw we already talked about on, okay. So I have to probably start topic now. Charger, so far I have not started. Something I told you about charger. whatever you expected, like, okay. So these are the different fast and slow and different kind of charger. Off-board charger you can see on like a petrol pump, na? You have a petrol, similar kind of size, similar kind of way. I mean, these are standard, or you have a charger typically varying from fast charger 15 minutes to your 8 hours, like, okay, fast charging and slow on a highway or so. This is a very standard rating. Many company have developed it, like a not Delta, 50 kilowatt, 125 ampere and 50 to 500 volt, whether you charge e-rickshaw or you charge Tesla cars of 460 volt. The car also can charge, e-rickshaw also can charge. That would fall up to 125 ampere, okay, or so. So not only this, ABB, then Schneider, then Nissan, I mean same rating, standard rating, but of course Tesla have a 250 or so, and this is wall mounted, typically another company or so. Some standard, so this we already typically talk about. Many kind of configuration of the charger, fast charger, we already have another Tesla charger or so. So AC bus and DC bus, then 250 kilowatt charger, fast charger, then this slide already talk about. On board, off board, we talk about, and typically these are on board, so many company are making typically, like. And of course our student also did something, I mean, about on-board charger with the power factor correction, because most of the charger for two-wheeler, three-wheeler, they don't have power factor correction. So I asked them typically, so I think I can escape it, but I think there is a slide, some of my students did something related to existing charger, like, I mean, typically. So all these they did. So e-rickshaw charger, so I asked, typically this is a e-rickshaw charger, one of my students brought from a company year back, and this was the internal part of e-rickshaw charger from Chinese, which is 4,000 rupees. So what they have, a heavy inductor and diode rectifier, so that inrush current is not there, and couple inductor. Inrush current is not there, and the current waveform is also not peaky in nature, and after that it's a flyback. First time I saw it, 600 watt 5 flyback charger. We teach in the classroom, na? Flyback is used only 1 watt, 2 watt, up to 100 watt. But this was 600 watt flyback, looking about like a 50 kilohertz, like. And this was the input current waveform. Like almost like a square wave with Indian student to study in the classroom with diode rectifier. Na? So they made, Chinese made of that, but of course the power factor was 0.82 and 55%. And peaky current, of course, existing charger. So I asked my student to look into that, how you can improve it. Okay, so this is typically, of course, so with the e-rickshaw itself, I think 2 PhD and 2 master students have a 30 transaction publication on e-rickshaw chargers. Okay, and I say this PhD is only 4,000 rupees. Okay, or something. People say we don't have a facility of research. No, you don't even need so much money for research, like, okay, but you add the value to it, okay. So they work out with the different converters and power quality improvement, like you can think about half bridge, many topology, like they work out, and power quality improvement in the grid. That was the, of course, concept for power quality improvement. Hello. I mean, typically, so you can think about a unity power factor and TID of supply current 3.3%, which was 55% or so. So work out with the many, now diode bridgeless, no diode bridge, are you able to follow? One converter for positive half cycle, another for negative half cycle with the isolation, okay, and then work out typically, not two, I think one more PhD, third PhD, Rahul also did on the same, typically like on. So no diode bridge, think about the simplicity, only 2 MOSFET, okay. So see, so cost effective. The MOSFET is hardly 25 rupees, are you able to follow? 40, I think 48 ampere, MOSFET is 22 rupee cost, like, okay, and no diode bridge for the battery charging, and very simple, and inherent power factor correction on the input. Like, so you can see power factor correction, okay, or so. So work out with the TAD 4.3% at even a full load like a 780, 800 volt, and then of course the other. They use the many topology like in e-rickshaw charger. So this is something related to design and all those. So work out wireless again this. So of course they use the different converters, like probably, I mean, guy are able to put as many converters as around 60 to 70 converter into it. Typically, not only first stage, virtually able to take second stage also with all these experimental results. And of course, many configuration, 3 additional configuration they work out also. And then bidirectional. So this is simple bidirectional, okay, no isolation, 4-quadrant operation which is required. Okay. So all the features. Then another isolated 3H bridge is a common, like you can have a bidirectional power wires, power flow, typically. So another bidirectional also. So now, then of course wireless we already talked about a little bit, so I can skip all these. These are the so many companies are making wireless. See it, around 10 company, just casually we saw it, is a 10 company on website who is manufacturing wireless chargers. So there is a good scope of wireless charging, and this distance is around like more than a feet or so, also. So that's another. So now coming to renewable, to your charging. So now we are coming on the topic which you want. It's okay? Can I devote 5 minutes? Okay, no problem. So what is that? Conceptually the solar, and you have a car on the park on the below, okay, on parking, then wind and solar for fast charging, typically in different parts of the world. Then you can see wind and solar, where the wind and not necessary solar may be there also. Then I give you idea not only the end page, but Ford is also making, Sun Power is also making same kind of product, like you have a sun, solar, you have a battery in the home, and you are parking, typically you are charging the car in the home itself, like also typically, and then reuse and all that battery concept also. Then typically when the Tesla for residential application, they start putting a home battery charging concept into the car also. So that's about, different technology which V2G and all these diagram, okay, that already we talk about. So a lot of companies start making this renewable based charging system in India and part of the world. Even your Adani, all are coming, Ather and all that, they are coming, this renewable energy based charging system, net metering based also. This already I have shown you, okay. So plenty of, you will find in India also, a lot of people start having this kind of charging system also. Okay. So what I asked my student 10 years back, he is in now Sweden in a company. 10 years back, not today, this concept is on 10 years and couple of PhDs also on that. I told here in the village, we have to charge 2-wheeler, 3-wheeler, maybe a small village. So what mainly energy should come from solar. You might have a battery here in the ground, like a petrol pump, but you should be able to charge 2-wheeler as well as you should feed into the load, so that it works as a microgrid also. But you may have a grid, you can interact with the grid, and someday maybe solar is also not there, grid is also not there. You will say for 2-wheeler, 3-wheeler or home that okay, we don't have electricity. Yes, you must have a small DG set here. The most enjoyable concept was the operation of these switches. I will follow. Apart from functioning of this converter with the interacting with the grid to take care of power quality on the grid by this converter, apart from that, interesting was the part of that operation of this switch. First time we look into a lot of papers on synchronization, but all were the simulation. So I asked my student, you have to synchronize with the solid state switch, maybe back-to-back IGBT. And how fast? Standard says 10 cycle, can you do less than 10 cycle? Because you have to connect with this. If grid is there, you connect with the grid, you can exchange the power to the grid or take power from the grid according to the slide which I have shown earlier. Are able to follow? But if you don't have this, then you must have a small DG set like. No, around 10 years, 15 years back, one of my PhD students, I asked this concept which I really did myself in Roorkee, for doing design and simulation. So I asked him to do implementation of it, then this guy caught directly this concept that this single phase induction machine can be used about 50% more generation for than the capacity. The efficiency increases of single phase induction machine and utilization is also better. So how you really encase into the concept, for typically single phase DC set only we put it, and then of course regulating the voltage here by the job of this converter. When this is connected, grid is not there, which regulates the voltage here. This converter, so it feeds the power remaining requirement of this if it is there like. So the interesting part, operating in isolation, this with the supplying the EV as well as to the load. Apart from that, synchronizing the grid, putting the power to the grid, taking the power from the grid, improving the power quality on the grid, it was the task of this converter. And when this is not there, solar generation, you take the power from the DG, okay, put to these loads, generate it at constant power, so remaining energy you can put it here or take from there. Like, so lot of modes, interesting modes, like typically. We asked one industry, of course, of renewable, they agreed to give 1 crore. They gave it some money. I put couple of PhD students on it. I mean, the concept we later on extended to, typically with the different modes and experimental results, we extended it to for later on for 3-phase. So this was another way how the switch was really configured, and this is, you can call it 2-coordinate converter like boost converter along with this, and but storage battery here also. But the interesting part was all control part of it, like and then operating the power quality on the grid side also, and different modes of operation. Then we extended it to 3-phase. So we have a 3-phase grid, improve the power quality of the 3-phase grid with this, and have a charging as well as fitting the home, battery and solar, and you can integrate the wind also, low cost wind with the permanent brushless generator. Permanent brushless generator can operate at variable speed, and no need to sense the speed, no need to sense the position, no need to sense anything except you put the diode rectifier with the boost converter and bring to the common terminal here, typically with the battery. So you can charge the vehicle here or you charge the vehicle on this side, both sides. Of course, 3-phase means you can extend certainly power rating to little higher, like on that side. Like, so a lot of interesting part here have been related to synchronization, because that was single phase synchronization, this is 3-phase synchronization. I can tell you the idea. Even this 3-phase synchronization, one of master student did, he is able to publish IEEE transaction paper on his smart grid. So there was no work. I am talking about 10 years story back. I mean, when smart grid journal started coming, Mahendra Reddy was the name of the student, and he has IEEE transaction only on synchronization of the system to the grid, like, because you don't have grid data. Then we start extending it to with different student for synchronization and reducing the time. Like, there is a lot of challenge for the control of these part of it, like also. So they are able to, of course, operate successfully and improve the power quality on the grid and charging and all those loads, all experimental. I mean, and when the grid is distorted by the current of supply is your converter, current is balanced also. Voltage may be unbalanced, voltage may be distorted, but you are not allowed to put the current unbalanced or distorted to the grid. Whatever power you want to take from the grid or you want to feed to the power to the grid, it should be balanced current and sinusoidal current, like or. So that was the interesting learning, and we extended to for many, like even for wind also, typically with the DFIG and other generator, like. So it works as a kind of active filter along with that solar generation, I mean, put to the grid, like, I mean, also. So there's another that you have a wind, you have a again solar and battery, of course, with the buck boost, okay, and then synchronization and typically your interesting part, not a single paper written back from the IEEE, because there was so many new aspects into it from the control point as well as configuration point of it. Of course, configuration is I have to give, and I told control you have to find new, otherwise you will not get the PhD. Simple, nothing. So they go to the somewhere to search like anything, this filter, that filter, this algorithm, that algorithm, and it work well without any problem, like also. So with this I conclude. I hope I am in time. So if you have any question, then I will be happy to answer. I hope you enjoyed it, the stories, more than the lecture. So still 15 minutes are there, man. So if any question is there, you will.
So let us give a big round of applause to Professor. Comprehensive lecture starting from history of TV and coming to such an advanced topic like how you are improving power factor, power quality in charger circuit especially. So thank you very much, sir, for your time, and we all are benefited with this lecture. मुझे लगता नहीं कि आप कोई ऐसा आदमी हो जिसको EV के बारे में अब ना पता हो.
But more important that you should have some startup out of it. Okay, I will be happy to that to see you. I mean, like at this age also. I mean, I was talking to some of my friends in different committees. I mean, like who are well wisher for me. Hidden well wisher you have always. Na? So I was talking like to him. So he say, what is your target? Oh, we have already 100 PhD, 150 PhD. We have already 109 patents. So what is next to be 100? That's to be the startup as a 100. Okay. So let's challenge for next year. Fortunately, government is very, you can call it. We are thankful to the government. Government is also extending indirectly the retirement age. People say I am already retired, but no. You have opportunity in the India, like of no retirement. Think about the government have increased the age for doctors. You know how much? 70? Doctors retirement age, AIMS is 70. All doctors are 70 years of age, retirement in hospitals. And you will surprise that most of the head of department who were appointed as a faculty in AIMS and good hospitals, or in good medical schools, they were before 2004 joining old pension scheme. They were getting salary about 40 lakhs, which we used to get before retirement. Like most of them, they took VRS and joined the other hospital with a salary of 4 crore. I don't follow. So their salary has gone for 40 lakh to 4 crore, these doctors, and this is your India model. I'm telling the fact now. And you know, when you go to government job, doctor feel inferior compared to the engineers. Whether you know the fact or not, if you have some doctor in your family and living in India, like common. So for doctors have such a opportunity that salary get 10 times after retirement, why you as engineers can't have a 10 times salary after you're completing the first inning of pension? If it is. If not pension, you can start your journey from the day one. And I'm just looking for the kind of the people who are doing the startup, the same concept. So I have a first startup with the Navy people. They came after VRS at the age of 50. They take retirement around 50 now. They came for startup and they are at the age of 56 today. And they have approximately, you know how much their salary they increased from 6 lakh. They started 50,000 per month the day then started the startup, and 6 lakh salary, and now they are on 32 lakh salary. And I'm very sure in next 4 years they will go to salary of 1 crore per annum, in addition to the pension of Navy. And item is what? E-rickshaw motor. I mean, earlier they developed axial field motor, they got it made and nobody was the user. So I told, look into e-rickshaw motor, yeah, nothing else you can do it. They reduced the cost from 4,000, Chinese are offering 4,600. They made the motor, made the motor in 3,600. And type with another industry, okay, they making and buying from them in 4,200, 600 rupee per motor is the, now these guys work very hard because they have a software of 70 lakh of FEM. So now they brought the cost to 3,000, a motor, BLDC motor for e-rickshaw, which is already still Chinese of 4,800. So 3,000 now, and they are going to ask the industry, and now you should give not 4,200, 4,500 less than China, because you already tested several thousand motors. So they are now more margin and it's going to be quite foolish. They have even employed PhD also, around 15 employees. Only for their R&D industry, they have a tie-up, industry manufacturing. So if they can have at the age of 60 at 1 crore salary, leaving the Navy itself, maybe hardly they might be getting 12 lakh per annum. Why you people can't think about the day one? I mean, like, so I have a concept, otherwise I could have gone, my friend is here. So he gone pulling my leg from last 25 years, why don't come to Canada? And another leg, still he pulled my leg, okay? Why don't come to Canada and US, okay? Leave with all the 3 children for 3 months and 3 months with them, with my friend, and my whole year will be completed and enjoy the life. But no, I thought let's struggle in it, look something for this country, okay? We should think about like, okay, and really there is a big future with that. So maybe next year there is an indication that government is ready to employ by increasing 1 more lakh salary per month. Okay, at the moment I am getting 1.5 lakh honorarium with pension. The next assignment supposed to be 2.5 lakh per month as a honorarium plus pension. Then certainly I have to do something for country. But the other big responsibility, what you call it, additional responsibility by government of India, that you have to look after what comes out of 250 crore, what comes out of 175 crore. I mean, sometime I become too rough I think it was online meeting with the mighty, I became too rough with that, person with the industry, as well as with the additional secretary and the person who is coordinating this from the mighty. Why you are really wasting money? And he says, sir, this, nothing doing. I wasted my time 1 hour. I could have given my lecture of 10,000 rupees for 1 hour and wasted, and next time you say, I will not come to. So then additional secretary jump into, sorry sir, will not. And say, sir, can you send some material? You know, I sent this slide. And this slide which I shown you, the multi-source slide. And it was unfortunately 32 slide in that. I cut a lot of slide and it remained 32 slide. And they mention into this, take this slide separately and mention it, okay, you take this kind of configuration. They mention 32 number slide of this presentation attached with the annexer with that. These guys, this kind of the people are there in the government, then I really feel sorry about it. But of course, this was some private engineering college from South and Haryana. There was a industry in Haryana, they have to develop the grid interface charging system for 250 kilowatt solar interface like also. So you have a strength. I mean, you are not going to lose anything. You are getting a lot of money, a lot of concept into it. And why don't become after 5 to 10 years around worth of 100 crore people? One of my students jumped into only a couple of months back with the